The topic for today is temperature. What temperature actually is? Temperature is the effect. Temperature is the effect of heat energy which determines the thermal state of a given substance. Is the effect of heat energy which determines the thermal state of a given substance. In other words, I can say temperature is a degree of hotness or coldness of a substance. Degree of hotness or coldness. If a body is at higher temperature, if a body is at higher temperature. Here I have used the word higher temperature with respect to surroundings. It means that heat energy will flow out of the body. Heat energy will flow out of the body. This I can say as vice versa also. That is, if a body is at lower temperature, in comparison to its surroundings, then the heat will flow into the body. Yes, now to measure how hot or how cold a body is, we have to define another term that is known as temperature. The instrument used for the measurement of temperature is known as thermometer. There are three different scales to measure the temperature. I can say temperature is a degree which tells us how much a body is hot or how much a body is cold. So the three scales to measure the temperature are mainly Celsius scale, Fahrenheit scale, and the last one is Kelvin scale. Temperature relation between the three scales can be written as temperature in Celsius upon phi is equals to temperature in Fahrenheit minus 32/9, which is equals to temperature in Kelvin minus 273/5. Now, there is another topic through which heat transfer takes place. That is, we have three modes of heat transfer. So the topic is modes of heat transfer. The first mode is conduction, second is convection, and the third one is radiation. Heat is energy in transit which flows due to temperature difference from a body at a higher temperature to a body at lower temperature. This transfer of heat from one body to other takes place with three routes, namely conduction, convection, and radiation. Thus, when there is difference in the temperature of the two bodies, then only heat transfer takes place, and that is also taken place by these three methods. First we'll discuss is conduction. The process of transmission of heat energy. The process of transmission of heat energy in which heat is transferred from heat is transferred from one particle of the medium to the other, from one particle of the medium to other, but each particle of the medium stays at its own position is called conduction. But the condition is each particle stays at its own position. Then this mode of heat transfer is termed as conduction. Before studying convection, let's define the two terms conductors and insulators. I can say good conductors or bad conductors. First is A. Good conductors. The substances through which heat energy can easily flow by conduction is called good conductors. Substances through which heat can flow easily by conduction are termed as good conductors. Examples of good conductors are metals in general are all good conductors. Metals in general are good conductors. Amongst metal, silver is said to be the best conductor. Silver among metals is the best conductor, followed by copper, aluminium and gold. The next term is bad conductors. Those substances which do not allow the heat energy to flow through them easily are called poor conductors or bad conductors. Those substances which do not allow heat to flow through them easily are termed as bad conductors. Examples of bad conductors are amongst the solid, glass, wood, clay, asbestos, rubber, plastic, etc. are poor conductors. Plastic, wood, clay, asbestos are all examples of bad conductors. Practical applications of good conductors. Applications of good conductors. First, cooling coils of an air conditioner. Cooling coils of air conditioner and the refrigerator are made up of copper as they readily conduct heat. Second, tip of soldering rod is made of copper. Tip of soldering rod is made up of copper as it readily conducts away heat to the solder. Now applications of bad conductor. Bad conductor help in conserving energy in a system. Glass, wool, cotton, slag wool, asbestos, enclosed air, vacuum, etc. are the common insulating materials available. Appliances like electric kettles, electric presses, electric ovens, soldering rods, cooking pans, etc. are provided with wooden or plastic handles. Because they are bad conductors of heat. Hence, heat from the hot appliance does not flow into our hands because they are bad conductor of heat. Slabs of ice are covered with sawdust or gunny bags to prevent them from melting. The sawdust or gunny bags contains a large amount of trapped air which act as insulator. Slabs of ice are covered with gunny bags to prevent them from melting. We wear woolen clothes in winter because the woolen yarn contains a large amount of trapped air. Since air is a bad conductor of heat, it does not allow the body heat to flow outward. We wear woolen clothes in winter as they contain large amount of trapped air which act as insulator and does not allow the body heat to escape and does not allow the body heat to escape. Animals in cold countries are generally covered with thick fur. The fur traps a large amount of air that act as an insulator. Animals in cold countries are covered with thick fur. The fur the fur contains a large amount of trapped air, contains a large amount of and thus act as an insulator Now let's learn what the law of conduction is. Law of conduction. In steady state heat, Q passing through a bar of length L and cross-section area A in time T, when its ends are at temperature theta H and theta C, such that theta C is less than theta H. In steady state heat Q passing through a bar of length L, and cross-section area A, capital A, in time T, when its ends are at temperature, theta H and theta C, such that theta C is less than theta H. Then Q is equals to Ka theta H minus theta C upon L into T. If I draw the diagram of the conductor, it is like this. L is the length of the conductor. This end is at temperature theta H and this end is at temperature theta C. X is equals to 0 and X is equals to L. So rate of flow of heat will be rate of flow of heat is equals to Q by T is equals to minus Ka del theta by L, where del theta by L is known as temperature gradient. K is known as coefficient of thermal conductivity.